Hi, today we will learn about lever. How does a lever work and what can it do? Levers are all around us and within us, as the basic physical principles of the lever are what allow our tendon and muscles to move our limb. Inside the body, the bones act as the beam and the joints act as the fulcrum. So what is a beam? What is a fulcrum? Let's look into it. So this is how a lever looks like. A lever is a simple machine that consists of two material components and two work components. The material components are the beam and the fulcrum. The work components are the input force, effort, and the output force, load. So a lever works in a way that the beam is placed so that some part of it rests against the fulcrum. In a traditional lever, the fulcrum remains in a stationary position while a force is applied somewhere along the length of the beam. The beam then pivots around the fulcrum, exerting the output force on some sort of object that needs to be moved. Okay, in short, when force is applied across a fulcrum, load will be exerted. Okay, remember, in a lever, the output force cannot be created without a fulcrum. A fulcrum is a point where the turning effect will be produced, which causes the input force to exert the output force. And do you know there are three different types of lever? We call it as class 1, class 2, and class 3 levers. And these three classes are different from each other based on the relationship between effort, load, and fulcrum, which means in class 1, the position of load, fulcrum, and force will be different compared to class 2 and class 3. And in class 2 and class 3, the fulcrum are at the same position, but the load and force will be at a different position. Let's look into it in detail. In class 1 lever, the fulcrum is always in the middle, with the load and force or effort at the both ends. But for class 2 and class 3, it always starts with the fulcrum. But the position of load and effort will be different. For class 2, it will be fulcrum followed by load and force. And for class 3, it will be fulcrum followed by force and load. Now let's look into few examples of simple machines that uses the principles of lever. For example, the claw hammer. Look at the claw hammer. The position of the fulcrum is in the middle and the load and effort will be at the ends. So the fulcrum will be in the middle, load and effort will be at the end. Therefore, this belongs to class 1 lever. Looking at the wheelbarrow, it has fulcrum at the end followed by load and effort. Therefore, it belongs to class 2, fulcrum, load and effort. Looking at human arm, it is followed by F. It starts with effort followed by fulcrum and load. It can be effort, fulcrum, load or the other way. Still, it belongs to class 1 as long the fulcrum is in the middle. Looking at the fourth example, pliers. In pliers or another example, the same example, common example will be scissors. The scissors and pliers will have fulcrum in the middle. We will apply effort here and the load will be placed here. They have the fulcrum in the middle, therefore they belong to class 1. Looking at nutcracker, the fulcrum will be at the end followed by load and effort. This causes them to fall into class 2 where fulcrum is followed by load and effort. For the last example, the sugar tongs, it has the fulcrum at the back followed by effort and load, where fulcrum followed by effort and load belongs to class 3 lever. Okay guys, what have we learned today? Today we have looked into what is lever, how does lever work and what it does. That's all. Thank you.